All right, welcome to the after work video. The lunchtime video today was going through the, actually I don't remember what it was. That was a long time ago, and I was doing I was actually working at my job, so my brain just snapping right from one thing to the other is kind of failing me at this point. So that's what the notes are for. I've got them right here, so I'll share my screen and read the notes, and I will share screen 2. Okay, so I'm sharing screen 2, so I'll pull the notes up. So last video, so you can see, yeah, I did the same kind of question answer thing where I had a thing I tried to just do based on my own knowledge, based on what I've been studying. I just tried to come up with a definition for the route distinguisher and for the route target. Unfortunately, that kind of failed me, but I have tools that I can use during the exam. One of them being help apropos, help topic, help reference, just any CLI command will be available to me during the exam. So using those CLI commands, I was able to come up with the following definitions for a route distinguisher and a route target. A route distinguisher is recommended to use, it must be unique, well, not must be, is recommended to be unique for each routing instance and for each PE. And then it comes in 2 formats. You can choose either one, and of course you can use any, you don't have to have them matched. So on one PE you can do one format, the other PE you can do the other format. So the formats are the AS number and just a number you make up, and or you can use an IP address and then a number you make up as well, and then you don't have to have any part of that matching. In fact, it's recommended that they are unique. That's different from the route target. That's got to match across routers. The format of that is going to be TARGET colon a number colon another number. These do have to match across all routers, and they're primarily just used for route filtering, import-export policies. So I guess I didn't say what a route distinguisher is used for. That's kind of missing from my definition, but that's kind of what I'm hoping this will do for me, is give me the correct definitions. When I studied this before, I found it was kind of, they were a bit hard to come by, the definitions of these two, and they are saying very clearly in this documentation that route distinguisher and route target are often confused in terms of their purpose in BGP and MPLS networks. I find that is absolutely the case. Oh, right, so here's how they are described in RFC 4364. RFC 4364 describes the purpose of a route distinguisher as the following: a VPN-IPv4 address is a 12-byte quantity beginning with an 8. Okay. So first, let's step back here. So let's think about what we're doing when we have VPNs. We're exchanging routes, just like we do without VPNs. But we're going to be exchanging secret routes that are different from the other routes we're exchanging. So how do we do that? Instead of just exchanging IPv4 addresses, as we would if we weren't in a VPN, we're going to exchange different kinds of addresses that are a combination of special VPN characters and the IPv4 address. So these are a 12-byte quantity beginning with an 8-byte route distinguisher and ending with a 4-byte IPv4 address. If several VPNs use the same IPv4 address prefix, the PEs translate these into unique VPN-IPv4 address prefixes. This ensures that if the same address is used in several different VPNs, it is possible for BGP to carry several completely different routes to that address, one for each VPN. Okay, so that's obviously very unclear, very hard to understand. Do they have to be unique? Do they have to match? It doesn't say there. It's really hard to visualize, at least in my opinion, what the final result is going to be, what it will look like in the config. So there's a reason why route distinguisher and route target are often confused in terms of their purpose in BGP/MPLS networks. And unfortunately, in my opinion, this does not this does not make that less of a reason. The reason is still there for me, even after reading this. It's just complicated. But I think the correct answer, which I'll write down. So for the route distinguisher, I think the most correct answer is a route distinguisher is prepended to the IPv4 routes that would normally be exchanged if there were no VPN, due to the routes being a part of a VPN. The route distinguisher is added so that instead of exchanging IPv4 routes in a VPN, route distinguisher IPv4 routes are exchanged. And I want to have the word special. And you can see that very clearly in the routing table. It'll have a special routing table for the VPN, and you will see, instead of just having regular old IP addresses, you will have the route distinguisher prepended to those addresses. So the correct answer is a route distinguisher is prepended to the IPv4 routes that would normally be exchanged if there were no VPN. Due to the routes being a part of a VPN, the route distinguisher is added so that instead of exchanging IPv4 routes in a VPN, special route distinguisher : IPv4 routes are exchanged. Okay, so I think that's a better explanation. It doesn't have a format. The format's easy, but yeah, this you can see was a very unclear definition. This is much more clear, so that's definitely a correct answer. Let's see if we can get one for the route targets. Typically, each VRF table on a provider edge PE router is configured with a unique route distinguisher. Depending on the routing design, the route distinguisher can be unique or the same for a given VRF on other PE routers. A route distinguisher is an 8-byte number with 2 fields. The first field can be either an AS, 2 to 4 bytes, or an IP address, 4 bytes. So it's got to be a IPv4 address because you've only got 4 bytes. The second field is assigned by the user. RFC 4364 describes the purpose of a VRF route target extended community as the following. Every VRF is associated with one or more route target attributes. When a VPN-IPv4 route is created from an IPv4 route that the PE router has learned from a CE by a PE router, it is associated with one or more route target attributes. These are carried in BGP as attributes of the route. Any route associated with route target T must be distributed to every router, every PE router that has a VRF associated with route target T. When such a route is received by a PE router, it is eligible to be installed in those of the PE's VRFs that are associated with route target T. Okay, so RFC 4364 describes the purpose of a VRF route target extended community. So I didn't even realize I was reading the definition or what will hopefully eventually become the correct answer for the definition of a route target, because there's such a word salad here. I didn't even realize that this was the definition for the route target. So let's read that again more carefully. Every VRF is associated with one or more route target attributes. So here's some more word salad. I just want to know if they're talking about the route target or not. So it's confusing when you have terms like route target attributes and VRF route target extended community. I can't tell if these are both route targets or if they're different. It's like if you use the word car, you know, are you talking about a clown car? Are you talking about a Ferrari? Like, car means a lot of different things. So, you know, if I just started saying clown car, you know, in a discussion about Ferraris, you wouldn't think I was still talking about the Ferrari, but they seem to be doing that. Like, they'll say VRF route target extended community, and then they'll say route target attributes, and it's like, well, are you talking about route targets still? Like what does the word route target, like is it a target? Is it even a like? Because if you just look up the definition of the word target, it's a person, object, or place selected as the aim of an attack. So are things aiming at the route target? Like how does the word, I guess that could be it. Maybe the routes are aimed at this somehow. Let's keep that in mind. The definition of the word target as being kind of an aim for an attack, and read this through, and hopefully it makes more sense. So every VRF is associated with one or more route to target. So target, and then we pretend that the routes are like arrows, attributes. So the target's going to have specific attributes. Maybe it'll have a 10-point ring, 20-point ring. It'll be a certain size. That's the mental framework I'm going to use to try to understand this better. When a VPN-IPv4 route, an arrow, is created from an IPv4 route that the PE router has learned from a CE via PE router. So the archer over here shoots out an arrow. The archer is the PE router. The arrow is the VPN-IPv4 route. And hopefully the route target is this, but we'll find out. It is associated with one or more route target attributes. These are carried in BGP as attributes of the route. Okay, so it almost seems like you've got the archer, and the archer shoots the arrow. So now the arrow has different attributes, and depending on those attributes, depends on how it hits the target. So let's just take this analogy and run with it, and let's say that one of the attributes is the tilt of the arrow, and it's tilted up like this. It missed the target going up. Let's say it's tilted down. It would miss the target going down. So I think that's what's going on. So that's the difference between a route target and a route target attribute. A route target is going to be the other PE. It's going to be the routes are going to go over, and then they're going to, it's not necessarily a actual physical target in any way, but the attributes will determine how it's hit into the how it is handled once it receives there. So it looks like my own definition I came up with could be pretty darn close to the ultimate right answer. Any route associated with route target T. So any route associated with route target T. So these are arrows if they were archers. So if we've got two targets here, but one target is T and the other one is Q. This is an arrow shot at T, not shot at Q. So any arrow shot at route target T or any route associated with route target T must be distributed to every PE router that has a VRF associated with route target T. When such a route is received by a PE router, it is eligible to be installed in those of PE's VRFs, those of the PE's VRFs that are associated with route target T. Okay. So I think I get it. So now let's keep the analogy. Right now, I think it's bust. I don't think it matches super well, but I'll try to make it match. So you've got the archer, which is a PE. You've got the arrow, which is a VPN-IPv4 route, and then you've got the route target, which is another PE, but it's the actual VPN on that PE. So let's imagine that. Let's draw this out with Microsoft Paint, and we're going to make some stick figures here. Okay, so we've got an archer here, and we'll give him a bow and arrow here. So it's going to be like that, and then he's got there we go. Yeah, there we go. So he's got a bow and arrow there, and now he's got he's firing off an arrow here. So we've got the archer himself, that's the PE router. We've got the arrow, that's the VPN-IPv4 route. Okay, and I'm gonna erase this. I'm not sure where this smudge came from. All right, and then the actual, what is the bow and arrow? Oh, well, we know the arrow is the route. I'm just thinking, what is the bow? I mean, the bow is just the BGP. It's the routing protocol that sends it out. So what's more significant for us to think about is the other side. And I think what you're going to have, the way I understand it now, is another archer with another bow, and the bow is going to be, as I mentioned, it's going to be BGP because that's how these routes are launched out. So let's give them a bow. Okay, but in addition to that, let's give each of these a helmet or a special hat. So let's say you shoot the arrow out and you hit this archer so that it sticks into his special hat, which has a target on it. So if this archer is wearing a blue hat and you shot the arrow out and it stuck into his blue hat, this archer now knows it must shoot an arrow out as well. Oops, I don't know how to flip this. Oh, okay. And it's got to shoot it out to every other archer that has a blue hat. So if this has a blue hat, the one who shot it, it's got to shoot it back. But then, of course, we can see we've got a routing loop, but there might be some mechanism like split horizon or something preventing that. But a route target is basically this blue hat, and we can actually make it blue. Oops, why did it? Ah, shoot! Now it's doing everything all wrong. I thought we could make it blue. Maybe not. Well, now the arrow is blue. That's just like super confusing. Oh, there we go. So. Okay. Well, I think maybe I can draw over the arrow so that it's black. Yeah, there we go. Perfect. Okay, so yeah, the blue hat is the route target because the targets are launched, and if they hit that, then the archer or the PE knows it's got to try to hit every other blue hat. So, and of course it can wear multiple hats stacked on top of each other. And then, of course, if it hits a red hat, it's got to hit all the other red hat ones. So you don't have to just wear one hat in this analogy. So hopefully this is helpful. More importantly, hopefully this is accurate. If anyone kind of knows if this is accurate or inaccurate, please let me know in the comments. This is my best understanding of what's going on based on my reading here, but I'll be honest, I'm pretty confused, and the sentence I understand the most of everything I've read so far is this sentence here. Route distinguisher and route target are often confused in terms of their purpose in BGP-MPLS networks. That one I understand. I totally get what that sentence is all about. But this one here, when such a route is received by a PE router, is eligible to be installed in those of the PE's VRFs that are associated with route target T. I think that means that if you get shot with an arrow and it penetrates your blue hat, you need to fire an arrow into everyone else's blue hat. And we're talking about hats with extra space. So I'm not saying to okay. Okay, so let's all right, let's continue reading here. The route target also contains two fields and is structured similar to a route distinguisher. The first field of the route target is either an AS 2 through 4 bits. That's not true. The first field is TARGET. Or an IP address, 4 bytes. And the second field is assigned by the user. Each PE router advertises its VPN-IPv4 routes with the route target as one of the BGP path attributes. Configured for the VRF table, the route target attached to the advertised route is referred to as the export route target. On the receiving PE router, the route target attached to the route is compared to the route target configured for the local VRF tables. The locally configured route target that is used in deciding whether a VRF-IPv4 route should be installed in a VRF table is referred to as the import route target. Okay, so let's go back here and see how to say what the correct answer is for a route target. I mean, to be honest, I just think this is the correct answer. I mean, it gives you the format there. In fact, it's more correct of an answer than what's given in there, because I do know that you need this. It's 3 fields. It's not 2 fields. So yeah, it's just used for filtering. There's an import. There's an export. That's pretty much all it's used for. If we go back to my Archer scenario, it's used to basically to determine when you get shot with an arrow, where do you need to shoot back? Like it's a target. It's a route target. So it's yeah, I think I got this one right. So this is the correct answer. So used for filtering and it's policies. Yeah. Not smash across. Yeah. Okay, so this one I got correct. All right, let's keep just doing the reading. C multicast routing, customer multicast, C multicast routing information exchange refers to the distribution of customer PIM, CPIM, which is, I should know this a little bit because, I mean, multicast was on the IP, the JNCIE-SP. So I believe I think it was. I don't remember actually, but I do remember learning a little bit about multicast at some point for some reason. And PIM stands for yeah, I want to say protocol independent media, but I don't think that's what it stands for. But yeah, let's just look it up. So yeah, what is PIM? Yeah. Well, this isn't it. Okay, let's do multicast. Oh. Okay, well, I guess I was close. Protocol independent multicast. So I said it was protocol independent media, but it's protocol independent multicast. So that's okay. Well, I'll take it. Join/prune messages. Customer multicast C-multicast routing information exchange refers to the distribution of customer PIM, C-PIM, join/prune messages received from local customer edge CE routers to other CE routers toward the VPN multicast source. BGP-MVPNs. BGP-MVPNs, multicast virtual private networks, use BGP border gateway protocol as the control plane protocol between CPE provider edge routers for MVPNs, including the exchange of C-multicast routing information. The support of BGP as a PE-PE protocol for exchanging C-multicast routes is mandated by Internet Draft IETF L3 VPN MVPN considerations -06.txt mandatory features in a layer 3 multicast VPN/MPLS VPN solution. This might be the one I already have up actually. No, it's not. The use of BGP for distributing C-multicast routing information is closely modeled after its highly successful counterpart of VPN unicast route distribution. Using BGP as the control plane protocol allows service providers to take advantage of this widely deployed feature-rich protocol. It also enables service providers to leverage their knowledge and investment in managing BGP-MPLS VPN unicast service to offer VPN multicast services. Sender and receiver site sets. Internet draft IETF L3 VPN 2547 BIS MCAS-10, which I believe is the one I have open here. Yeah, but this one, let's see here. Oh yeah, this one here is different. So I think I'm going to add, before I read further, I'm just going to add these to my notes. It'd be nice to read all that, but I just don't know if I have the time. Describes an NG-MVPN as a set of administrative policies that determine the PE routers that are in sender and receiver site sets. So let's put that down as the definition of NG-MVPN. A set of administrative policies that determine the PE routers that are in sender and receiver site sets. Okay, and that's this one. A PE router can be a sender, a receiver, or both a sender and a receiver, depending on the configuration. A sender site set includes PE routers with a local VPN multicast sources, VPN multicast sources either directly connected or connected via a CE router. A PE router that is in the sender site set is the sender PE router. A receiver site set includes PE routers that have local VPN multicast receivers. A PE router that is in the receiver site set is the receiver PE router. Provider tunnels. Internet draft IETF L3 VPN 2547 BIS MCAS-10.txt defines provider tunnels as the transport mechanisms used for forwarding VPN multicast traffic across service provider networks. Different tunneling technologies such as generic routing encapsulation, GRE, and MPLS, multi-protocol label switching, can be used to create provider tunnels. Provider tunnels can be signaled by a variety of signaling protocols. This topic describes only PIM-SM, ASM, signaled IP GRE provider tunnels, and RSVP-traffic engineering, RSVP-TE signaled MPLS provider tunnels. In BGP MVPNs, the sender PE router distributes information about the router tunnel in a BGP attribute called Provider Multicast Service Interface, PMSI. By default, all receiver PE routers join and become the leaves. What? God damn it. That's not. Oh, okay. Okay, that is the plural form of leaf. Okay, my bad. Sweet. Okay, good. Of the provider tunnel rooted at the sender PE router, provider tunnels can be inclusive or selective. An inclusive provider tunnel, probably I-PMSI provider tunnel, enables a PE router that is in the sender site set of an NVPN to transmit multicast data to all PE routers that are members of that NVPN. A selective provider tunnel, S-PMSI provider tunnel, enables a PE router that is in the sender site set of an NVPN to transmit multicast data to a subset of PE routers. Is it Friday today? It's Friday today. Okay, well, I don't know what to do with myself after this video. Okay, so let's see here. Understanding, so this is where it starts to get, oh, okay, no, this whole section is just for next generation multicast VPNs. Okay, so understanding next generation MVPN control plane. The BGP next generation multicast virtual private network MVPN control plane as specified in Internet draft IETF L3 VPN -2547 BIS MCAS -10.txt, so this one here, and Internet draft IETF L3 VPN -2547 BIS MCAS BGP -08.txt. So it looks like there's a new one. We've got 06, we've got 010, but I don't have 08 in my notes yet. Distributes all the necessary information to enable end-to-end C-multicast routing exchange via BGP. The main tasks of the control plane, table 1, include MVPN discovery, distribution of provider tunnel information, and CE-CE C-multicast route exchange. So this is the next generation MVPN control plane tasks. We've got two columns here. One is all of the control plane tasks, and the second one is the description of the control plane tasks. So the first control plane task is MVPN auto discovery, and a description of that is a provider edge PE router discovers the identity of the other PE routers that participate in the same VPN. Next control plane task is distribution of provider tunnel information. And this is a sender PE router advertises the type and identifier of the provider tunnel that it will use to transmit VPN multicast packets. The last control plane task is CE-CE C-multicast route exchange. A receiver PE router propagates C-multicast join messages, C-joins, received over its VPN interface toward the VPN multicast sources. Oh my God. This is like the worst topic ever. BGP MCAS-VPN address family and route types. And before I go on with that, I will add 08 to my notes. Internet drafts IETF L3 VPN 2547 BIS MCAS BGP 08.txt introduced a BGP address family called MCAS VPN for supporting next generation MVPN control plane operations. The new address family is assigned the subsequent address family identifier, SAFI, of 5 by the Internet Assigned Numbers Authority, IANA. A PE router that participates in a BGP-based next-generation MVPN network is required to send a BGP update message that contains MCAS-VPN network layer reachability information, NLRI, and MCAS-VPN NLRI contains route type, length, and variable fields. The value of each variable field depends on the route type. 7 types of next generation MVPN BGP routes, also referred to as routes in this topic, are specified in Table 2. The first 5 route types are called auto discovery NVPN routes. This topic also refers to type 1 through 5 routes as non-C-multicast MVPN routes. Type 6 and type 7 routes are called C-multicast MVPN routes. So we've got types. And we've got a lot of types. We've got 7 types. So I don't think I can memorize all of those types. I don't think I need to memorize all of those types. But you can see that is quite complicated. I'm kind of hoping that I can just, because this is a lot of information here. And I don't know the extent to which this will be on the test. So I kind of don't know what to read and what not to read. And, if I don't read enough, I won't know the material to pass the test properly. But if I read too much, then I won't know the other material. There's lots of other topics. So I guess I'm not sure kind of where to go with this. I kind of want to just jump over to a example and then just do a few examples and then move on. I kind of feel like I've read kind of enough at this point. It's just kind of coming over me like a wave, and it's if I'm going to be tested on a particular particle of that wave, I don't know, it all just washed over me. So I don't really know what value I'm even getting out of just reading everything. So especially since it's a hands-on test, I think I'd get more value out of that if I had multiple choice questions on the test as well. But it's really just a hands-on test. So I think I'm going to do that. I'm going to see if there's, oh my God, some examples. So yeah, so here's some really, okay, yeah, so here's some examples for NBGP multicast VPN extranets. So I think I'm going to be doing these. I'm going to be doing this example as well. And then this final example here. Yeah, so I think I'll just be doing these 3 examples. And then if there's anything I don't understand, I'll go and I'll read about it at that time. So let's make goals, or let's say next video goals. Oops, and we're gonna have, yep, so we're gonna have 3 examples. Yep, so this configuring extranets here. All right, and then we're gonna have this one here. Oh, we've also got a redundant virtual tunnels I'm not sure what this is all about, but that doesn't have the word NVPN in it, which at this point is a word to me because I've read so much about it. Okay. Yep, so, and then of course I'll be doing this one as well. Okay, so I've got my goals for the next video. We'll just be doing those examples. And after that, I'll be moving on. I really want as much hands-on experience as I can because it is going to be a hands-on exam. I think, and of course, part of the running themes I've constantly said is that this channel is more about concepts, not commands, because just a randomly memorized command really can't do that much for you if you don't understand what it does. And not only that, if you do understand the concepts, you can figure out the commands pretty easily using the question mark and the help. So, you know, reading all this is something I definitely think is a good thing, but I just don't have, because I mean, I spent the first 45 minutes of this video just reading stuff, and I got through the first two sections. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There's 18 sections. So if it took me, let's say it took me a half an hour to get through 2 of them. So that'll be 9.5 hours. So that would be like 4 hours, something like that, 5 hours. It's just a lot of hours, and I've only got an hour for this video, and I've only got a certain amount of hours until the test too. It's in September, so. All right, let's see if there's anything kind of eye-popping here. Yeah, this kind of pops out to me. So multi-protocol BGP based multicast VPNs, also referred to as next generation layer 2 VPN multicast, constitute the next evolution after dual multicast VPNs, draft Rosen, and provide a simpler solution for administrators who want to configure multicast over layer 3 VPNs. The main characteristics of multi-protocol BGP based multicast VPNs are: they extend layer 3 VPN service RFC 2547 to support IP multicast for layer 3 VPN service providers. They follow the same architecture as specified by RFC 2547 for unicast VPNs. Specifically, BGP is used as the control plane. They eliminate the requirements for the virtual router VR model, which is specified in Internet Draft Rosen VPN MCAS, multicast in MPLS/BGP VPNs for multicast VPNs. They rely on RFC-based unicast with extensions for intra-IS and inter-IS communication. Multi-protocol BGP. Oh, that's interesting. It looks like there's examples within here that were not listed there. Yeah, so it looks like a more basic, like, yeah, look at this. The most basic, kind of most useful example to me is just buried in here. That's kind of upsetting to me. I almost want to submit a downvote for just that, because like this is seriously going to be the most useful lab for me, just as configuring MBGP multicast VPNs. And look, it's something that's hidden on this page, and I can't tell. Like if I go back to the multi-protocols user guide, like I don't have any way to find that. Like it's just completely cut off from being able to be easily found. Like yeah, I'm going to need to do that. So I'm going to need to go to here and then to here. Now, is this even next generation or is it draft Rosen? Because if it's draft Rosen, I don't want to do this one. Okay, and it does not say which one it is. It says it's NBGP Multicast VPN, but as we learned from the reading, there are two different kinds, and the next generation kind replaces draft Rosen. So there's, if this is a draft Rosen lab, I would not want to do this one. Okay, I'm going to do the on this page navigation bar hides important examples such as example configuring NBGP multicast VPNs. I almost was unable to find this documentation because it was buried within the configuring multi-protocol BGP multicast VPNs section, and impossible to be found unless by accident or if you already knew where to look. All right, so the on this page navigation bar hides important examples such as example configuring. Really, it can't. Why can't it? Configuring MBGP multicast VPNs. I almost was unable to find this documentation because it was buried within the configuring multi-protocol BGP multicast VPNs section and impossible to be found on the main page. Found on the main multicast protocols user guide page when expanding, after expanding all. Okay, so I think that's going to be good. So the on this page navigation bar hides important examples such as example configuring NBGP multicast VPN. I almost was unable to find this documentation because it was buried within the configuring multicast BGP protocol VPN section and impossible to be found on the main multicast protocols user guide page after clicking expand all and searching for examples. Okay, so I think that's good feedback because I almost did not see this. And this is literally like the exact lab I need to do. I was kind of afraid they didn't even have this lab. Okay, but I think that's going to be it for this video. A lot of reading in this video. Unfortunately, I just don't see the value in doing that too much. So the next video, I'm going to change to having it be a hands-on video. And this is the first one I'm going to do because this is the most important. And I'll do at least one of these labs, if not a few of them, and get some hands-on experience. I might need to make sure I move on from this pretty quick, but the next topic after this will be EVPNs at the request of a commenter. And then after that, I'll be going back to the regular order. The next section will be BGP, but I can gloss through that pretty quick because I covered that pretty extensively in 961. All right, but stay tuned for the next video where I get some more practical hands-on experience about multicast VPNs. So thanks for watching and see you in the next one.